integration. I also want to note here that U substitution can be required, but not always. Well, almost always there is some type of U substitution within these type of problems. So in terms of review, we noted the power chain rule, which was all the problems before, and every single problem always ended up with some integral of u to the n du after we did the substitution, which gives me 1 over n plus 1, u to the n plus 1, plus the constant of integration. As long as n does not equal -1, we'll talk about what happens when n is -1 tomorrow. It's a transcendental function, as it turns out. And that was what we did yesterday. Now, in today's problems, you might see a problem pop up like that, but I don't believe so. I think that Desmos is going to keep them all to trig. So in practice, and this is what kind of I'm giving you on Monday, you kind of have to feel for the problem. You have to know and practice doing the problems, because the last 3 days it's been like, you're right if you got u to the n du right before as your second to last step, some constant times the integral of u to the n du. That's not going to be true here. All right. So first off, let's go in terms of our basic memorizational. So these need to be memorized. All right. And that's that. And we're just going backwards. So the integral of sine of x dx. Now the derivative of sine, and it gets tricky here. What's the integral of sine? What function gives me a derivative of sine?
Negative cosine.
There we go. So we know the derivative of sine is cosine. So the derivative of negative cosine of x would be the antiderivative. So you got to be careful on that one. Derivative of sine of x is cosine of x, but the integral of sine is negative cosine. All right, the integral of cosine of x dx is what?
Sine.
Yeah. Positive sine of x plus the constant of integration. And these are the first and foremost the ones you need to make sure you do not make a mistake on. That if you're making mistakes on these ones on the AP exam, your score will likely go down. So there's certain things on the exam where it's like, if you get that wrong, if you do not have that memorized and fixated, your score is going to go down rather quickly if it's a lot of stuff. So these are the two main ones that you're going to see a lot on the exam, all right? The derivatives and the integrals of basic sine and cosine. And then we have the other ones, but we should still note, and they might actually do pop up in your homework, the integral of secant squared x dx is tangent of x plus c. It doesn't happen as frequent in here on these type of problems, but it does happen. The integral of cosecant x dx equals negative cotangent of x plus c. The integral of secant x tangent x dx is equal to secant of x plus c. And the integral of cosecant x cotangent x dx is negative cosecant x plus c. Now these other four, they do not happen very frequently on the AP exam, all right? Because most of the times that you have to do these types of problems, most of these times you just do something like a U substitution type problem. So typically we just want to make these as U substitution, but ever so often there might be one question on the multiple choice that literally utilizes this memorizations. Now, when looking at the integrals, one of the things, and this is more test taking strategies than anything, you want to ask yourself, remember, ooh, I forgot how to take that integral, but I know how to take derivatives. So let me look down through the options A through D and see which one that if I took the derivative would give me that integrand. So this is something this is a skill set that's also very useful. For example, if I saw the integral of secant squared x and I'm like, what is the integral of secant squared? Well, let me look at the options. Oh, wait a minute. One of the options is tangent of x. If I took the derivative of tangent, I get secant squared x. Oh, there's my answer. So that's type of stuff that you do there. But with these ones up here, you need to have those memorized. You're going to see them, like I said, quite a bit. Now, in a basic example, we might be combining our previous knowledge with what we just learned. Like I said, maybe question 1 or question 2 might be this type of question, but that's basically where it comes and ends. So for example, the integral of 3x minus sine of x dx. Question 1 or question 2 could be this problem, all right? A nice, simple, there's no substitutions needed. Usually, this is like I said, it's like the first multiple choice question or maybe even the second multiple choice question is usually a basic non-substitution type integral that we can do here. And this is when, we're going to do this the normal way. And so as we know, we just integrate each term. So what do I get when I integrate this? The idea here is we're just going to focus on just the 3x first. So how do we integrate 3x? Everybody should have this down and mastered by now. Just integrate the 3x. Every single student in here should be able to do this. If you cannot integrate 3x, you're not passing this exam. Guarantee you. Just looking at 3x. 3.
And then would it be cosine of x?
We're just integrating the 3x. Just the 3x. That's why I said you're overthinking it. If you listen to me when I'm saying, what is the integral to 3x? All you're doing is basically 2 math problems. And so we're trying to do the first one right here. So what's the integral of 3x? 3, and then what? Okay, good. So you can do, some people will do 3 halves right away. If you follow my process, it's 3 times 1/2 x squared. Some people did 3x squared and then over 2 because they know they're going to add 1 to the power. No matter what, you get 3 over 2 as your coefficient, minus the integral of sine of x, which is? It's negative cosine of x. So it's negative cosine of x. Now, of course, most people will just realize, okay, well, if the integral of negative sine of x is negative, then minus the integral of minus sine is going to be positive cosine. So hopefully you feel comfortable and you'll say, oh, this is just go straight to plus. It's a minus, and you'll change that to a plus cosine of x plus c. Now, I have it written as 2 different lines just so that we can see how we're doing it step by step. Now, sine x, cosine x, negative sine x, negative cosine x. If you take the derivative, you just go around in here. And if you integrate When you go in the other direction, that's the integral. All right. So, most of the times you don't actually, I only draw what's in red. And if you know the direction for derivatives, then the integrals go in the other direction. So you reverse the direction for integration. So the derivative of sine is cosine, derivative of cosine, negative sine, derivative of negative sine, negative cosine, derivative of negative cosine is positive sine, and it keeps repeating. So if you want to integrate, you just go in the opposite direction. Just a little helpful tidbit. Okay. Chain rule forms. And of course, the idea here is that sometimes there's going to be a baby within the function and the problem. And so as such, we have u is some f of x and du is f prime of x dx. And we make this substitution into here and we end up getting a problem that's like sine of u du. And most of your problems today are going to look like this. So most of the problems you're going to get today will be like an integral of sine of u du, or a constant time, or multiplied by a constant, or the integral of cosine of u du, and so forth. So what's the integral of sine of u du? Don't overthink it. If you look up into your notes.
Negative cosine u plus c?
Boom! Correct. It's the same thing. You're just a different variable. And so remember, like this is like your second to last step. So you would integrate it as such, and then you would plug back in your u for your final problem. The integral of cosine of u du, that's a equals, I forgot the equal sign, negative, is positive sine of u plus c. Just make sure you get the signs right. That's the biggest problem. They work for the other rules. I'm not going to write down all the other rules, but for example, the integral of secant squared of u du would be a tangent of u plus c. As I stated, most of the times these problems are going to be multiple choice, and on Desmos, I don't know if they are all. You can take the derivative of tangent, and you would get secant squared. Of course, you'd have to use the chain rule. Now, helpful step to quicken u sub of linear. Basically, these type of problems do come up more frequently on the exam, and you can also do the u substitution, but it becomes easier if we just don't. So for example, if I have the integral of sine of ax dx, then when I integrate it, what's going to happen is I'm going to do a u equals ax. So du equals a dx. So I get 1 over a du equals dx. Basically, that always happens. So what I'm going to do here is I'm just going to jump the step, and I'm going to get negative 1 over a cosine ax plus c. The integral of cosine ax dx equals positive 1 over a sine of x plus c. Basically, here's what I'm telling you about these ones. It'll save you time on the exam because they do pop up a lot more frequently, of like sine of ax, and they can be combining them with other problems. And this can be confusing to some because when you try to do u substitution, some people will try to use u substitution with multiple terms, and it becomes problematic. All right. So for example, In this problem, this following problem example is an example of problem that could require use substitution, but we can get away with it without having to do that. So the example is the integral of 3x to the fifth minus cosine of 7x dx. So this is the problem here. Now, what I get a lot of people do is they go u equals 7x and they jump right to here. All right. The problem that does is that you're going to be looking at this and then you're going to try to apply it to here. And so you're going to come into lots of problems. So you have two options. One of the things I like to do when I do this problem is I like to just separate this type of problem in I don't actually technically write it down, but I'll say, oh, this is the integral of 3x to 50x minus the integral of cosine of 7x dx. Now, I might do this, you might do this a little bit more so than I do, but this is what goes on in my mind. This is what needs to eventually happen and that you are visualizing in terms of seeing. Because now when I do the u substitution, I'm only doing the u substitution and applying it to here. And so as such, I get 3 parentheses 1 over 6 x to the 6 minus, well, the integral of cosine is positive, so it's going to stay minus. And I can either use the u substitution or I can just know the rule. Oh, it's a constant. Remember when we have linear babies, whenever there's a linear babies, your integrals are just going to be 1 over. So I would get 1 over 7 sine of 7x plus c. Now, if this doesn't click to you, then you would say du equals 7 dx, 1 over 7 du equals dx. So this piece becomes the integral of 1 over 7th minus 1 over 7th integral cosine of u du, which is minus 1 over 7th sine of u plus c, and that's how you get to that final little piece. The process really isn't that hard, but it becomes very time consuming when you're doing a multiple choice question. Now, most of the time, time is an issue for students who are stronger. All right. Students who are getting 4s and 5s will have more time issues than the students who are struggling. All right. So what do I mean by that? It usually feels like the opposite, right? If you are struggling and you don't feel as strong on the exam as somebody else, you would think that it would take you longer to do the multiple choice. It's typically the opposite way for when it comes to AP Calculus, because you're really working, those individuals are really working to solve every single problem, and they understand, but they have to get through the work. And so what happens is that if you don't find ways to limit how long it takes to do the problem, when you are strong and you're potentially getting a 4 or a 5 on the AP exam, you can really run out of time when it gets to the later problems. We'll do a lot of review. We'll really teach you how to get that endurance to the problems. Now, what about a more traditional problem? One that I'm going to have you walk me through. Let's do this one. The integral of x cubed sine of 1 minus x to the fourth dx. Can somebody tell me what they believe or what we're going to do and explain to the class why we're going to do that? Nobody?
I know we're gonna have a fraction.
Okay, we know we're going to have a fraction. Good. Okay, that's some good knowledge right there. We know my answer will have some type of fraction. Okay. What else do I know? What do I notice about this problem that has similarities to the problems that we've done it before in the past days? The main answer I'm looking for here is we have two functions of x. There's multiple functions of x. As such, this screams out u substitution. So what's my u?
1 negative x4.
1 minus x to the fourth. Okay. What's my du?
Negative 4x to the third power.
Dx. All right, and solving for the what do I get as my next step, which is mostly the most important step of my u substitution and the most difficult part of the u substitution, I feel. What do I get next? The idea is to bring the constants over. That's the next step. So I get negative 1/4 du. That's the big step right there. Equals x cubed dx. Got to get used to that process for the last step of moving the constant over to the du side, which in turn makes this equal to what? What do I get next? There's my x cubed dx. So that's just part of my du part right here. What do I get next? Same type of step. Now it should feel almost exactly the same as what you've done on all your u substitutions before. Negative 1/4 integral of what? What does it become? The x cubed is going to go away because that's my du piece. What do I have left over? No. There's no cosine in there. Still an integral, which I haven't taken the integral. No, neither of those. You can't just be deleting things. There's something that's there that has to stay there. What wasn't accounted for within my substitutions? No. I don't even see a 5. Look at here. What is not accounted for? What does not have, like I underlined it or I put, what did I not identify within there with my substitution?
Sine.
Sine, yeah. Sine. The sine has not been accounted for and the sine is going to stay. And so it becomes sine of u du. The u is 1 minus x to the fourth. So I substitute out the 1 minus x to the fourth for u, and that x cubed became that negative 1/4 du piece. And then I integrate. Now, as people were saying, now what do I get as my answer? So this is the second to last step. Every problem, or mostly every problem, is going to look something very similar to this. Sine of u du, cosine u du, and so forth. So what do I get now? Negative or positive? My answer is my final answer going to be negative or positive?
I think it's going to be negative.
50% chance? Yeah. What is it?
Positive.
Yeah, it's going to be positive. You got to make sure. You have to make sure that at minimum, you know if the answer is going to be positive or negative. you have to make sure the integral of sine is negative cosine. So the integral of negative 1/4 sine would be positive. You have to get at least the minimum, the signage. So it's positive 1/4 in, as I think I've seen, cosine of u plus c. And what do I do as my final step? Always
Plug in 1 minus x to the 4th power.
and there I go. Now you can get some substitutions might have chain rule involved in them, okay? It happens. So in this next example, I have the integral of cosine to the 4th 3x sine of 3x dx. Now this problem is technically yesterday's topic. This problem, I don't did I assign it on yesterday's? I might have. This problem actually is not a trig integral. And I know that looks weird, like, but it's trigs. Isn't that a trig integration problem? And actually it's a power, this one actually turns out to be a power chain rule problem. But I want to throw that in there, that just because you see sines and cosines, just as a reminder, does that not mean that your last step is going to be integral of sine or integral of cosine, all right? I want to make sure we do that. So the first thing we do is do what to something that looks like this? What do we do to a problem that looks like this?
Make it calculus fun.
Correct. So this is the integral of bracket cosine of 3x bracket to the 4th sine of 3x dx. All right. What's going to be my u?
Cosine of 3x.
Yeah, so it's cosine of 3x. I get a lot of students that are just like, oh, u is 3x, and they have to take, you have two different functions of x. You have a cosine function of x, and you have a sine function of x. So you can't just think of it as 3x's. The 3x's would be the same. So you gotta place it together. So du is equal to
Negative sine 3x times 3dx.
yeah, so negative 3 sine of 3x dx. Or if you'd had that times 3 at the end, perfectly fine, which gives me, and I'm going to do this to save some time, negative 1/3 du equals sine of 3x dx. So now this problem becomes
Negative 1/3 integration sign. And then it'll be u to the power 4 du.
correct. Whenever you do those substitutions, you're not going to see like multiple u's going around. It's going to be like sine of u, cosine of u, those type of things. You'll see those around there. So it just, you won't see multiple u's when you do your step. All right, and our final steps is really simple. This is just the material that we did the last 3 days of classes. Negative 1/3, parentheses 1/5, u to the 5th plus c, which gives me negative 1/15 cosine of 3x to the 5th power plus the constant of integration. I think I've done enough of those last problems where we can just bam, bam, thank you, man, type of things. Look at another example. I know it's a lot of just examples, and that's basically the best thing we can do. This one's just one of those odd problems out. So secant square root of x, tangent square root of x, all over the square root of x dx. This is one of those problems that just looks a little weird, but it looks a little harder than it actually is, as long as we can determine what we need to do. So my first step when I look at this type of problem, I want to do what? What do I want to do?
Make it calculus friendly.
So integral secant x to the 1/2, tangent x to the 1/2, x to the negative 1/2 dx. Now I want you to note that these two functions of x are the same. Oops, wrong. I meant to highlight. These two functions of x are the same. And then the other one is different. Which means that the one that is multiple times is going to be my u. And the other piece that's different, and since there's only one of them, has to be my du piece. So my u in this problem is
secant x 1
no,
over
no.
Is it the x to the negative one?
Oh, close. It's x to the positive 1/2. Now the secant tangent one is the one that's very different. You are going to see two u's within that problem. That's the only situation that you'll ever see. But there's a lot of reasons why I know x is to the 1/2. First off, the derivative of secant does not give you tangent. The derivative of tangent does not give me secant. So you cannot be the whole entire thing of a secant or a tangent. That can't happen. Second reason why I know it's x to the 1/2 is that I see x to the 1/2 repeated twice and then something different, which would be x to the negative 1/2, which is the derivative of x to the 1/2 off by a constant. So that tells me that that is my u, so therefore my du is 1/2 x to the negative 1/2 dx. And just like the example I did before, 2 du equals x to the negative 1/2 dx. So this is my u, this is my u, and this is my 2 du piece. So I now get what? Something integral. What do I get? Same step right here. Utilize the substitution. I've even boxed it for you. We're not actually integrating. We're just substituting the stuff in. This is the same part right here. To start off this problem is the same thing you've been doing for the last 3 classes and all of the examples we've already just done in this class. The first part of the next step is the same things you've been doing over and over. Thank you. 2 times the integral. That's the first thing I'm looking for. Did you know that it's a 2 that goes out in front? Okay. And now we're going to look into stuff. And well, like I said, I did not take into account the secant or tangent. So my answer has, or my current problem, still has secant. I'm going to replace it with u. Tangent, I'm going to replace it with u du. And like I said, this is one of those problems where secant tangent is the only, and cosecant cotangent too, but they're the only ones that look really different than all of the other problems you've seen. So that's why I wanted to do it as an example. And this is one of those just memorization ones. So you get 2, well, the derivative of what gives me secant tangent? It's just secant of u. So that's one of those weird ones. Like I said, it rarely ever happens. And this is a problem that you would typically just look at the derivatives, look at the option choices, and try to take the derivative of those ones. So I get 2 secant x to the 1/2 plus c, and which is, of course, 2 secant square root of x plus c. And so what I would do on the AP exam is I would find this one, and I would say, okay, if I took the derivative of this, I get 2 times secant tangent. Oh, secant tangent, that's what I had. Times x to the negative, times 1/2 x to the negative 1/2. Oh, it's going to have an x to the negative 1/2, which is the square root, 1 over square root of x. So you can take the choice here, and it should feel somewhat comfortable that if I took the derivative of this, I would end up getting secant tangent with a square root on the bottom from the chain rule piece. And that's typically how you would actually go about doing this specific problem, but I just wanted to give you that practice. That's what I have for you today. You'll have your practice. It is Delta Math. Make sure you're doing it. Show up to tutoring. Remember, it's never too late to start signing up for tutoring, to start showing up for tutoring if you are struggling. There's a lot of good work that goes on there. Please make it your way there. Eric just is, the man is amazing. He finds so much joy to be working with everybody and spending his own time, and really enjoys the work that is being put on, not by everybody in the class. And if anybody else would like to join, I know he would be very happy to even get more students coming in for any session. So if you haven't been showing up, still time, try to do so. And if you are, I'll see you over around 2:30 for his tutoring session. Take care, everybody. I'll see you tomorrow.